In this video, we're going to convert the point that's given to us in polar coordinates to its Cartesian coordinate representation. We're also going to make a sketch of the point to make sure that the polar coordinate matches the Cartesian coordinate in the basically right quadrant and everything we need it to. So let's first by sketching the point to make sure that it's going to make sense later on. So the original point we're given in this case is in polar coordinates -2, 3 pi over 4. So again, a couple things to note. In this case, we have a minus or a negative polar radius. So this is going to tell us to flip across the origin, which basically means we'll take the original angle and add pi to it. So instead of 3 pi over 4, we'll basically be at 7 pi over 4. But first, let's just practice plotting polar coordinates in general. So if we have a different point, say, this is the point now with a +2, 3 pi over 4. So again, I'm just adding this point to show. The first thing we do is really, we think about which angle we're moving at. So again, if we're at an angle of 3 pi over 4, that would place us basically somewhere along this general curve. And the next thing we need to know is basically how far in that direction are we going to move? And in this case, we're moving a distance of 2 from the origin. So this could represent the point of +2, 3 pi over 4. However, the point that we really care about is this point -2, 3 pi over 4. So the way in which we think about this is we take the point that we had earlier with the positive r value, and we're going to flip this across the origin. Basically, we're going to end up now in quadrant 4 instead of quadrant 2. We're still moving a distance of 2 from the origin. However, we are now landing in quadrant 4. And instead of that angle being 3 pi over 4, the new angle for us, again, starting from the positive x-axis and moving around, this angle is 7 pi over 4. So this is our point, actually. It is -2, 3 pi over 4. Or equivalently, this is the same thing as the point 2, 7 pi over 4. All right, so again, the big thing to take away from this is the original point we're given in polar coordinates, and the point is some point in the xy plane in quadrant 4. So let's actually now make moves to convert this to Cartesian coordinates. And the way in which we convert to Cartesian coordinates, or we go back and forth between Cartesian and polar, is we use the transformation equations that relate r and theta to x and y and vice versa. So in this problem, we want to know, how can we get the Cartesian x and y values if what we're given in the problem are r and theta values for polar coordinates? So we move on to our transformation equations here, and we ask ourselves, if we start with x and y, how do we get to r and theta? Or if we start with r and theta, how can we get x and y? So the equations that we actually want to use are on the right-hand side here, where we can get both x and y from the original r and theta that were given. So let's go ahead and start doing that. So if we're looking for the x value first, we have x is equal to r cosine theta. So we can basically plug in what we're given in terms of the polar coordinate. So r in this case is -2, and our theta in this problem is 3 pi over 4. So we have x is -2 times the cosine of 3 pi over 4. 3 pi over 4 is related to the angle of pi over 4, whose cosine is square root of 2 over 2. However, since 3 pi over 4 places us in quadrant 2, cosine is negative in quadrant 2, so this is actually equal to a negative square root of 2 all over 2. So we can see some cancellation is going to happen. The 2's will cancel, and also since we're multiplying a negative number by a negative number, the negatives will go away. So we find the x value is equal to positive square root of 2. And now that makes sense because the x value of the point that we really care about in the problem, we are on the positive x-axis side of things. So the x value is positive here. All right, let's do the same thing for the y value. We have y is equal to r sine of theta in this case, plugging in r, which is -2, and plugging in the theta that we're given, which is 3 pi over 4. We see that y is equal to, well, -2. And now 3 pi over 4 again is related to the angle pi over 4. Sine in quadrant 2 is positive. So sine of pi over 4 is square root of 2 over 2. We can do a little cancellation here. The 2's cancel. We don't have another negative number, though, to cancel the negatives out. So this actually just becomes y is equal to minus the square root of 2. So in Cartesian coordinates, our original polar coordinate can be represented by xy is equal to positive square root of x and square root of 2 and negative square root of 2. And again, if we're thinking about this point, the x value is positive. We're on the positive x side of things for our point that we care about, and our y value is negative, and we are on the negative y value side of things for the point that we care about. So it looks like this point that we just found in Cartesian coordinates, it's going to match up with the point that we started with in polar coordinates.